That's so weird. Seeing a screen of your screen of your screen. So, let's see here. So, don't know. Can they hear me? Okay, great. So this is my first time doing a live stream, so it's gonna be really on the fly.
Are you gonna live stream the workshop?
Yep, we're actually live streaming right now. Yeah. So out to
Where are you streaming to?
my YouTube channel.
Cool.
Yeah. So this should be pretty interesting. So there are actually 7 people that are watching right now. That's pretty cool. Can you hear me? Talking to them. We've actually got 12 viewers. I mean, that to me is really cool. We've actually got 14 people already.
That's good.
Yeah, on the live stream. That's amazing.
Cool. So HDMI. I'll give you that and I'll start setting up the mic. So that just needs to go from your adapter to the HDMI guest one here.
Okay.
So,
Okay. So I'll let you set this up.
yeah, that's cool.
You're the expert.
Those 2 jack leads just need to go from the back of your interface into these 2.
Okay.
So you can do that.
Okay. So just getting set up here for the people that are tuning in from. Okay. So just getting set up.
That's from your Mac, I think.
Yep. Haha. That's funny. At least I know it works.
I mean, to be honest, the mic in that might even just be good enough.
I was just thinking that.
Like, that was blaring.
Yeah.
Shall we not even bother with this?
Yeah. Let's not even bother.
Yeah.
I think. Yeah. Yeah.
It seems overcomplicated for what?
Yeah. Hopefully it won't be too loud for people. Oh, so we got quite a few people coming in from the UK.
Oh, nice.
Yeah. So before we get, so we got 10 minutes yet. Let me meet all of you really quick. So.
I think you'll need those though to hear your speakers.
Okay.
But I'll set those up. So
Hi, John. Nice to meet you. Are you undergraduate or
First year.
First year. Okay, cool. Have you ever done any sort of coding or anything before?
No, I
No.
never did program.
Okay.
I was just interested in maybe in the future.
Yeah.
Or
Cool.
our future, I think more.
Awesome. Good to know. Good to know. Okay, so what was your name? Mark. And you are Chris? Yeah. Chris, Mark. I'm terrible at names, so. Robson. Nice to meet you. And have you, are you undergraduate? Masters. Okay, great. So have you done coding before?
Not really.
Not really.
Well, I started a few months ago.
A few months ago. Okay, cool. And what are you studying?
Digital audio engineering.
it's the same masters as I'm on.
Okay, great. So that's pretty like VST math. Is it more like kind of theoretical than coding?
Well, we have one module that is basically maths
Okay.
with signal processing, and
Yeah.
the other module is focused on C++. Apart from the engineering research,
Nice. Who teaches the C++?
Christos.
Christos. Okay.
Yeah, he's internal to the uni.
Oh,
yeah.
okay. Cool.
Is it Christos Morales or a different?
Sorry?
Is it Christos Morales or a different Christos?
Different Christos. Tudors.
Hi. Josh.
Josh.
Nice to meet you. Undergraduate or master's?
Masters on the electronic music composition.
Okay.
So my experience of coding is quite limited.
Okay.
I use Max MSP
Okay.
modules.
Awesome.
And,
Great. Cool. Okay. A lot of new programmers.
Hey, Jamie.
Yes.
No, I love it, yeah.
I'll be seeing you in a couple weeks. Hi,
Yeah.
Max. Josh. Nice to meet you. Coding experience?
A little bit.
A little bit.
C sharp.
Okay, great.
And I've done Mac MSP stuff before.
Yeah.
Yeah, I'm on the same course as Ross.
Oh, great. Well, this should be exciting.
Cool. So in here it's all routing.
Okay.
All good.
Awesome.
We just want to make sure that your Mac and the speakers aren't feeding back when you're talking. So
Yeah.
we just want to test that. If I don't know if you can kind of go live briefly to just do a quick test.
Okay. So, yeah, I mean we are live now.
Okay, cool. I guess maybe it's just worth checking to see if they can hear your music and your voice.
Yeah.
Before we get started. Everyone got their phones on Do Not Disturb, right? I had to pick the one chair that didn't have one of these. Oh, is it?
Okay. So what I'm going to do before we start, I'm just going to blast this out on the socials real quick. Oh, okay. What about this?
Yes. Yeah.
Okay. Do I need to?
Cool.
Okay, cool. So I'm going to mirror this. System preferences. Okay. Great. Are y'all excited? I'm excited. Does anybody know about OBS offhand?
I've used it a couple of times.
Yeah.
But
So I can add a source. So
Yeah.
Tell me if I'm wrong, but I could add a source where it shows.
You can show your, so you can, well, you want to see your webcam as well?
Yeah.
Yeah. Do you wanna have it?
Yeah, that would be fantastic, actually. Okay, so let me pull this up. OBS. So there we are.
Okay. Okay, great.
Yeah.
So then you should be able just to go sources and add down here.
Yeah.
And you want to go video capture device. And then it should give you the option to bring up your webcam. FaceTime HD camera. Hopefully if you press OK,
Hey.
you can just chuck that in the corner.
Nice.
There you go. Or you can you
Yeah.
can resize it however you like, but yeah, there you go.
Nice one.
No worries.
Thanks. Cool. So we will make this small.
So you probably, I'm not sure, by default does it have the your laptop output audio source as well? It looks like it's got the mic.
Oh no, the streaming was all right.
As in your audio source.
My
from your
audio
is
source,
fine.
yeah.
Okay, cool.
Yeah, I'll just check with them again here real quick. Yeah, they're saying it's all good.
They can only see the upper left of the screen.
Yeah. Let's see. So, yeah, what's that about?
You need to.
Oh yeah, I
Display
just
capture, there you go. You can resize it.
Oh right, well that's happened. Detail so the screen needs to be like zoomed out. Okay. Did you want
I would just bring it in from the top left.
yeah,
Yeah.
yeah, because it's changed the resolution, hasn't it?
Yeah, that giant HDMI.
Great stuff. Cool. Okay, is it showing the right?
Yeah, you just want to close that because it's just showing the.
This is so cool. We got like 23 people and counting tuning in. And so I just need to actually make sure that we're able to see the video itself. That's hilarious. This is so. Okay. All right, so only thing is, why is it showing my browser rather than, let's go back here. So this video display capture.
Do you have two screens going on, or have you mirrored the one?
I've mirrored the one. Huh. Okay, I'm gonna do this for a second. There we go. Okay, now we're good.
Just hit OK, right?
Yeah. Cool. Is there a way that I could actually fold this out? Pop out chat, that's what I want to see. Great. Does start without me needing to get a gin.
Yeah, we're missing a trick as well. We should have got a bottle of gin in.
Okay. Great. So I'm gonna go ahead and get started a little bit. So, okay, so hey everybody, thanks for coming. My name is Josh. I am the founder of the Audio Programmer. I say founder because and put that in quotes because it feels to me like something that's still just fairly small. It's just a YouTube channel that I started a couple of years ago when I was in university myself, just trying to learn this, some of the basic concepts that I'm going to teach you about today. So what I'm going to do today, since there are so many people here that have never coded before or just starting to code, is I'm going to really walk you through more kind of basic concepts and just some of the underlying fundamentals of building a plugin. And you're welcome to follow along and code along with me, but don't feel like you have to. And what I'm going to do is I'm just going to give you just the real basics. Okay, this is going to be a talk that's going to be about 2 hours and 15 minutes. But it could easily be something that could be like a 10-hour talk. So what I'm giving you is just like the very, very tip of the iceberg. And I hope that you get some things out of it. And we'll be talking between kind of audio concepts along with some like basic coding concepts as well. Okay, so and if you have questions in between, I'll try to answer them. So feel free to raise your hand or interrupt me, and we will do our best to keep this as seamless as possible. So to start out, all of you know that we're coding this audio plugin in C++. Does anybody know why C++? Like, why not JavaScript? Why not Max MSP? Why not Java? Yeah. Anybody? Go ahead.
Performance reasons?
Yeah, so exactly, performance reasons. So the biggest thing with audio is that you have this continuous stream of information that's happening. So if we think about an audio stream, like most of you have worked in like music production or worked in some sort of DAW like Ableton or Reaper, and you see a representation of an audio wave that has a wave, and then if we were just to take that waveform and we were to take a look at it, those are going to be values. And then if we were just to look at each point on that waveform, each point is going to be a value between -1 and +1. Okay, so and that is exactly what it is. So when we think about a waveform, like what is it actually doing? The waveform is actually instructions that are telling our speakers how to move. So the speakers are gonna, so if you think of speakers as being able to move forward or backward, they're gonna have a certain range that they're gonna be able to vibrate, right? So what that waveform is actually doing is telling the speaker how to reproduce that sound using the vibrations of the speaker. Now going further into how does that relate to audio and audio coding. So if we were to just take a look at that wave and how that would be represented in a computer, then we would look at it as a memory block that would contain essentially a whole bunch of numbers between -1 and +1, right? So you have a whole bunch of numbers between -1 and +1 that are giving instructions to our speakers on how to vibrate. Now we have two speakers, right? Because we're operating in stereo in this scenario. So now we need to think. So now we need to think about two speakers. So we need to give instructions to the left speaker. We need to give instructions to the right speaker. Okay. So as he was saying, the reason that we use C++ is for performance reasons. So we want everything to be real time dependent. So if you've ever used a MIDI controller before, the second that you hit a key on a MIDI controller that's connected up to some sort of software instrument, you want that to respond in real time, really quickly, as if you were playing a real piano or playing the real instrument. Okay, and in order to do that, to keep a long story short, basically we use C++ because other languages kind of have their own memory management that they kind of do in the background. But with C++, you can get very close to what they call close to the metal, which means that we have a lot more control, and that makes it a lot more efficient, but at the same time a little bit more difficult as well to manage. So we have the kind of core language, which is C++, and then on top, so the core language of C++ is like the very foundational language, right? And then you think, okay, well, now we have this other layer that we're calling the Juice framework. But what's the Juice framework? So, like, let's say that we were making a video game, right? And that, we think of a video game, any video game is going to have some sort of physics library, right? Because we're going to have something moving. We're going to have to make rules for what happens when an object hits another object, so on and so forth. Now, if you can imagine making a physics engine, every time that you want to code up a game would be a nightmare, right? You'd be spending months, possibly years, just creating the library itself. So what we do is we have these things that are called frameworks. Frameworks give us kind of tools, or we could just call them blocks of code, that enable us to do the job easier, right? So we still have to, the framework still has to be kind of modular enough where we can create whatever we want to create, but at the same time, it gives us building blocks. So one thing that the Juice gives us as an audio framework is it gives us the ability to talk directly to the sound card that we're working with in our computer. Okay, it also enables us to. So let's say that we are creating a plugin or creating an audio app, and then we want to we're working on a Mac. We're building our app, and now we want to deploy that app to Windows, or we want to deploy it to iOS or some sort of other operating system. Normally, you would have to do that separately, but with Juice, what you can do is you can actually create mostly an app that is cross-platform, so it works on all different operating systems from one piece of code. So you only have to worry about developing that piece of code once. That's really convenient. Also, if you've worked with audio plugins, you may know that that you have different audio plugin formats. So you have AAX, VST, AU, and so on. With Juice, you can actually just hit a button and it will actually deploy for all those formats from one piece of code. Okay? Otherwise, you would actually you'd have to work with those individual pieces, the VST, the AU, SDKs, what they call SDKs, and you'd have to work with those individually. Okay, that would be a real pain. So that's essentially the reason why we're using the Juice framework today. So what I've done, so just to start off, I'll just close this here. So what I've done is, if you downloaded Juice, what you do is you just kind of open the Producer, right? And then what I'll do is I'll just create a new project here. And then when you create a new project, this is what it comes up with. So you can create a couple different types of applications. Okay, the only ones that I've really ever messed with have been these two ones down here in the bottom left-hand corner. Audio application. So that's like something it's an audio application, but it's not a plugin. Like, let's just say Spotify, right? Like, this audio application, it's not a plugin that goes in the DAW, but it plays audio. So something like Spotify could be something that you could create with using Juice, using this audio application template. And then you have audio plugin. Audio plugin, of course, is a plugin like a synthesizer, a VST effect that you would open up inside your DAW, like Ableton or Pro Tools, and you would use it within a DAW. So today what we're going to do is we're going to create a very, very basic, the most basic kind of, it's almost like the hello world of an audio plugin, which is a gain slider. Okay, and all we're going to do is we're going to be able to move the gain slider, and it's going to be able to turn up or down the audio that's coming into it. Okay, but it sounds very simple, but within that there are going to be a couple fundamental concepts that we're going to need to cover. Okay, so what I'm going to do is I'm just going to click on audio plugin, and by the way, all of this is up on my GitHub as well, and I'll give you the link to that. Actually, I can give you the link to it right now. So let's just do that very quickly. Oh, I need to tweet this out. And so let's go to GitHub. So the address for the repository is github.com/theaudioprogrammer/gain, so with a lowercase g, and workshop with a capital W. Okay, and then from there you will be able to actually get the code for this. Okay, I won't really cover Git today because that would just take us into, like, Git is something that could take hours in itself, but that's where you could get it. Okay, so going back, so what we're going to do is we're going to create a new project. I'm just going to delete this here so we don't confuse ourselves, and we're going to call this gain. I'll just call it Gain Workshop. Okay, and I will just put it here in one of my folders. And then what I did was I just went down to the bottom right, and then I hit the create button. So that creates the project. Okay. So there's, like I said, there's so much that I could cover here, but I'm just going to give you the very, very tip of the iceberg. Okay. So what that's done is that's given us a template here that has four files here. So you can see that we have this one called plugin processor.cpp, we have plugin processor.h, then plugin editor, cpp and h files. Okay, so what's a cpp and what's an h file? So these are C++ files. Okay, so these are source files. So essentially you have what's called a header file. Okay, where it's kind of tough to describe this until I actually show it to you, but essentially a header file, to put it very briefly, a header file just gives you kind of a snapshot of, like, what is this source file about, and then the CPP file is kind of the inner guts, the implementation of how we're actually implementing the source code. Okay, so now what I'm ready to do is I'm ready to get started. So right up at the top center here, you'll see this button here that says, like if you're on Windows, you might see a different one here, but it says, if you hover over it, it says save and open in IDE. So what this means, so Juice is essentially a place where I can control the source files myself, and then when I'm ready to go, I just hit this button that says save and open in IDE, and that's where I actually do all of my coding. Okay, so I'm just going to save it and open it. Okay, and so now if you're on Mac, we're in Xcode, or you might be in Visual Studio if you're on PC. So now what I'm going to do is I'm just going to look at these source files themselves. Okay, and there's a whole bunch of stuff here. There's a lot of stuff that I haven't even actually used myself personally yet, but what I'm going to do is I'm just going to give you kind of a very broad overview of a plugin, the fundamental parts of building a plugin, and then we're going to take a very general overview of actually just trying to get audio actually routing through the plugin itself. Okay, so does anybody have any questions so far? Anybody? Okay, feel free to ask. Okay, cool. So a plugin is divided into two parts, right? So you have the what's called the processor. The processor is the place that is actually routing the audio through. So actually the raw numbers, like if you had any sort of digital signal processing algorithms that you were using, those would all be in the processor. So think of the processor as kind of what's happening behind the scenes, the raw math, so to speak, of a plugin. Okay, so the user is not seeing this part. Okay, this is all happening behind the scenes. Okay, under the hood. Then you have the plugin editor, and the plugin editor is what the user is actually seeing and what they're actually interacting with. Okay, so and there's going to be a connection between that editor and that processor, right? Because let's say, for example, we're making a gain slider, right? That's going to be turning up and down our audio. So if we can just envision that from a high level concept, then what we'll have is we'll have a slider, right? That's going to have a control that we're going to be able to turn up and down, and the user's going to turn that up and down. Now there's going to be a number that's going to be attached to that slider, right? So now that number that's attached to the slider needs to relay over to the processor, and then in the processor, that is what's going to actually modify the audio signal itself. Okay, so the editor is what the user sees, processor is what's happening under the hood. Okay, any questions about that? Okay, so now we're going to get down into a little bit more into the guts of what we're seeing. Is this big enough for you to see? Do I need to?
Maybe a little bit more.
Okay, so now you're going to, let's see here, fonts and colors. See, this is a test for me because I don't remember offhand how to actually make it bigger. Yeah, it's there. So, okay, so if let's just try this again. There we go. Okay, how's that?
That's better.
Yeah? Great. So now I'm going to, so now if we look here at the top left, we see that we are in our plugin processor .cpp. So this is where the actual algorithms, and if you have like any sort of reverb, any sort of delay, distortion, what have you, that is going to be happening at the end of the day here in the processor. Okay. Now, what I'm going to show you is, I know that some of you are just getting familiar, or maybe only vaguely familiar with coding and concepts. Okay, so I'm just going to get rid of all this unnecessary writing here. And there's a lot that I could explain, but I'm just going to try to keep it as high level as possible. Okay, so what we have here, if we look at this void, blah, 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 process block. Okay, so what this does here, so this is what's called a function, and we know it's a function because what we do is we see that we have these kind of curly braces here, and this marks kind of the beginning and the end of the instructions for that function. So this is executing a task. Okay. Now, to give you a high-level overview of what the process block does, process block is essentially where the audio is happening in real time. So what's happening here is that if we don't do anything at the moment, the audio is just going to basically route through, okay? And that's it. There's nothing that's going to be happening to it, okay? So first thing that we'll do is we'll actually just build this really quickly. I just need to actually make sure that it actually builds properly, and I can pull it up in Ableton properly and everything. So what I'm going to do is I'm just going to build this plugin. Just that little play button up there in the top left-hand corner is where I build the plugin. And this will ensure that we don't have any sort of errors or any problems in our code. And then another thing about C++ is that sometimes the first kind of go around, it can take a little while to build. So that built successfully. We know because down here it says build succeeded. Okay, so that's a good sign. Now what I'm going to do is I'm just going to open this up. I'm just going to open this plugin up in Ableton here, and hopefully it'll appear. Okay, so it's not there. 1 second. I might just need to. Let me look in here real quick. Game Workshop. I might have to just rescan here very quickly. 1 second. Also, it's rescanning it for me. Okay, so we're just going to wait for a second for it to hopefully come up with our new plugin here. Okay, there it is. So what I'm going to do is I'm just going to get rid of all these other unnecessary tracks. So we have one audio track, and we have this plugin. It's called Game Workshop. And then I'm just going to take it. I'm just going to drag it. Oh, that's the wrong one. That's my that's the finished product there. So there it is. So at the moment it has nothing. It's just a blank screen that says hello world. But what you'll see, so if I actually just go down here to, and I just put in let's just look for a loop.
Just quickly explain how Ableton knows it's there.
How Ableton knows the plugin is
So
there.
once you've built the Juice project, how has that now been picked up in Ableton?
Okay.
What's Juice doing?
Oh yeah. Okay. So what this does, this is when you build the plugin, it actually kind of compiles it into the package, which is like like in this case it's called a VST. So it's a VST format package. Now here in Juice, in the producer, I think it's not in here. Let me look here. So if we go in here. So as I said before, the benefit of Juice is that when you build it, it actually builds all the different types of plugins for you, right? And here in the producer, we have a location where we're basically saying, okay, compile this code, put this into a package so that somebody else can use it in a VST format, which is what DAWs use. And then here in the producer, it actually has the location where that is actually where that actually builds at. Does that answer your question?
Yeah.
Okay.
So it's in the default location for the VST or AU that the Mac usually uses. So Ableton just knows it's there when it boots up because it's been already exported to that location.
Yeah. So on computers there is a default location where those files are supposed to export. When you open up Ableton or any other DAW, it says where are all my plugins? Where are all my plugins? And it will look in, no matter whether you're using Ableton or Pro Tools, it'll look in the same location. Okay, so when I actually built the plugin, it automatically put it in that location. So Ableton already knew kind of where to find it. Okay, so let me just look at my sound card here because I didn't hear any audio. Now, hopefully, I'm just going to turn this down a little bit. Great. So we've got this. So it's just loop playing. Now we can see that here, this is the audio coming in, and this is the audio going out. We see that nothing's happened to it, right? We see that it's at the exact same volume. right? So if we think of, so we go and we think, like, okay, so we have this stream of information. These are floating, what they call floating point numbers, right? So they're numbers, they're decimal numbers in between -1 and 1 that are coming in into our plugin, and they're going back out, right? It's exact same numbers. And then we say, okay, if we're going to be thinking about a volume, right? Like, let's say that we had a incoming value, just one value, and let's say that value was 1, right? And let's say that I wanted to decrease it, right? Let's say I wanted to cut it by half. What would I do? What would I do there? What do you think I would do?
Multiply it by 0.5.
Exactly. Yeah. So if you want to decrease the volume, all you'd have to do is just take all the incoming numbers that are coming in and you multiply it by 0.5, right? Because that would just cut everything kind of in half, right? It wouldn't be audibly in half. That's a different story. But so what we'll do, first thing that we'll do is we'll actually do that. We'll give it a little. We'll do it by something a little bit more drastic than 1/2. Just so you can distinctly see the difference in volume. So as I said, we're here in what's called the process block. So the process block is kind of our main, where the main audio work is getting done. Okay, so this is actually where the audio is actually coming into the plugin. Okay, and anything that we want to do, we're doing in this process block. And this process block gets called over and over and over again. Okay, what we're going to do is, at the moment, we have a for loop. Do people know what a for loop is? Probably not. But I'm going to keep it. I'm going to keep it super, very, very high level. Okay, for everybody. So essentially, what this first for loop is doing is it's actually going through. It's actually changing between the speakers. Okay, so it's actually going the left speaker and the right speaker. Okay, and then this auto pointer channel data equals buffer.get right pointer. Like, what does that mean? Okay, so what this actually means is that it is actually getting. So you basically have this. So you have this buffer, right? So a buffer we can think of as a container that's holding our that's going to hold our audio, right? At the moment, it's empty. There's nothing in there. So what we're doing is we're actually saying, hey, buffer, space that is supposed to hold my audio information. I want to grab a right pointer, and what a right pointer means is that I'm going to actually write information into this buffer. Okay, so I have this audio information that's out here, and what I'm going to do is I'm actually going to take the audio information. I'm actually going to put it into the buffer. Okay. Any questions about that? Everybody got it? Okay, so that's what the buffer.get right pointer is about. Is it saying, hey, I'm just grabbing the audio information and I'm going to put it into this buffer. Okay. Now, what I'm going to do is I'm going to make another what's called for loop, and I'm going to do the buffer.get num samples. So this plus sample. So I'm just going to type this out, and then I'm going to explain to you what it's doing. Everybody ready? So okay, so now we have this, as I said before, we're going through, this, so we have this process block that's getting called, and then just coming down here, don't worry about all this information. Just coming down here, we have this for loop that's going back and forth between channel 1 and channel 2. What I'm doing is I'm getting the right pointer to our buffer, okay, which is the space where we're holding our audio information. And now what I'm doing is I'm going through the actual sample that's in the buffer. So I'm going to the actual audio information, that's the actual values that are in the buffer. And I'm saying, okay, what I want to do is this sample, okay, so if you think of that as like 1 point on the waveform, I'm going to take each sample that's coming in here, and I'm now going to multiply this by 0.02, right? So we talked before about, okay, well, if we multiply it by 0.5, then it's going to cut it in half, cut the magnitude of the wave in half, making it smaller. If we do it by 0.02, it's going to make it even smaller, isn't it? Okay. So let's just compile that, and let's see what happens. All right, so we're just going to compile this, and then what I need to do here is I'm going to actually save this. Let's call this gain. So if you ever do this, then what you actually have to do is you have to actually close it out and open it again. There's another process that you could do that's actually quicker than this, but I don't want to confuse anybody. So we're just going to do it like this for now. So now I'm just going to open my old project called Gain. Now this plugin is built so when I built the plugin, it replaced the old one. Okay, just overwrote it. So now, what do you expect will happen when I play this?
Probably going a bit quieter.
Yeah. So hopefully, fingers crossed, we'll have an incoming signal that'll be the same as what we remember it, and then over here it should be quieter, right? So let's see what happens. And see, that's what we see, right? So we see that the gain before it goes into the plugin is a lot higher, is a lot louder than when it comes out of the plugin. So we know that our plugin is working, right? And once again, what we're doing is, if we think of this guitar loop, right? So like if we look at this wave as it is, once again, these are just values between -1 and 1. Right? So if we zoom way in here, and then all we're doing is we're just taking each one of these values and we're multiplying it by 0.02. Okay, so that's actually what we're doing in code. Okay. So that's where we're at right now, right? So now we say, okay, how do we control this, right? How do we actually create a slider now, right? Because we want to have some control and raise and lower the volume. So what we could do is we could look at this number and we could say, okay, what if we could just have this number change as we change the dial, right? So what I'm going to do is I'm going to do what's called creating a variable. Now, and what I'm going to do is I can create a slider by using just the slider keyword, which is with a capital S, slider, and then I'm just going to call this gain slider. Okay, so and what I've done there is I've created it as a class member variable there, so that because in my plugin editor CPP file, I'm going to need to use this in a couple different places. Okay, and in order to use my gain slider and give it the parameters that I need, so I'm going to need to give it a location, right? I'm going to need to put it actually on the screen somewhere. I'm going to actually need to give it some sort of values. So I'm going to need to tell it, okay, what's the minimum value? What's the maximum value? I'm going to need to tell it what type of slider that I want it to be. Yeah. And in order to do that, I'm going to need this gain slider to be accessible throughout different parts of my plugin editor. Okay. So the first part here. So we have this. So we have this first function here that we can see that it says it's just the same name as what this file is, Game Workshop Audio Processor Editor. Okay, so we can just see that it has the name there. It's not like a function like void paint or void resized. Okay, this is what's called. This is getting a little bit technical, but this is what's called a constructor. And what a constructor does is it's just something that's called once when you instantiate the plugin. Okay, so the first time that the plugin is created, basically it calls this function just once, and that's it. And so anything that you just need to kind of stand up at the very beginning of your plugins, like all your sliders, you want to create them for your user to see when you first create your plugin. So that's when this constructor is actually called. Okay.
So is the constructor called when the plugin's like first instantiated, or is it any time that the window is open?
So for the editor, okay, this is a good test actually. I believe that it's called anytime you actually create the window. So if I look here, let me take a look here. Yeah, so we have this create editor, and then returns a new. So this what this tells me is that this is created and destroyed when. So I say destroyed, like it's actually kind of gone. It's actually kind of cleared from memory, like when you actually close. I mean, I hope I'm not wrong in saying this. I'm sure somebody will tell me. But when you actually close the UI on your plugin, it actually destroys it. Okay, it actually gets rid of it. It doesn't exist anymore. And then when you call it back up, it recreates it again. I hope somebody probably Daniel from my forum, who always corrects my mistakes, will probably tell me that I'm wrong on that. But
the process is still going. That's just the editor.
Yeah, so that's just the editor. The processor's still going. So like, you know how you have an audio, so you have like audio processes that are happening, right? You've changed some parameters. Now you close the UI. The UI is gone now, right? We don't need those resources anymore. So it like gets rid of them. That's the beauty of C++, is that it could actually like once you've actually closed that, like that's gone from memory now. Okay. And but the audio process is still actually happening, right? You don't want a scenario where you close your UI and then your audio process just stops, right? You wouldn't want that to happen. So the processor still exists, but the editor gets destroyed. Okay. So what we need to do, so we have a gain slider, and what we're going to do is we're going to give it a style. So we're just going to do like a linear vertical, a vertical slider. We're going to give it some initial parameters, and we're going to put it actually on the screen. Okay, so once again, the name of it is called gain slider, and then I can use this function called set slider style. Okay, and sometimes these the way that you actually have to access, so you have like the slider style, and remember I was showing you how you have linear vertical, linear horizontal. So sometimes these classes can be a bit hierarchical, if that's the right word, in that you have to go into the slider class, you have to go into the slider style kind of section, what's normally called an enum. Okay, so you have to go into the slider, you have to go into the slider style, and then you go into, okay, I want the linear vertical slider. Okay, otherwise it doesn't know what you mean. So I'll do a slider, slider style, linear vertical. Okay, so that's why it's a little bit wordy like that. So I'm going to the slider class. So if you think of like a, I don't know, what do they call it? Where you have like the table where you have like capital A and then you have 1 and 2 and then
Bullet point list, isn't it?
what's that?
What bullet points?
Yeah, like bullet points, exactly. Yeah, like this is kind of like bullet points, like sliders. So if you think of slider as like your head, like at the top, and then slider style is like a bullet point, and then you have linear vertical, linear horizontal, blah blah blah. You know, as kind of like the sub points underneath that slider style. Okay.
Like folders on a computer.
Yeah, like folders and subfolders almost. Yeah, exactly. So now we have this gain slider set range. So we need to tell it what the range is. So this one we're going to make it just 0 and 1. Okay, so for now what we're doing is we're just saying, okay, so the most we could do, so the loudest that it could be is whatever the volume that's coming into it, right? Like we can't get louder than because a signal, like if it's a signal of 1 and we're multiplying it by 1, we end with 1, right? So it can't get louder; it can only get softer in this gain slider. Another note: if you're creating this on your own, be very, very careful. I'll actually show you a little function there, like at the end, because especially when you're creating these, like when you're starting off, and even me now, it's very easy when you're routing audio things to like really like blow your ears out, especially like if you're wearing headphones. So one good thing, one piece of advice that my friend Ivan Cohen gave me is to actually put a kind of a hard limiter or a clipper at the very end of your signal path to ensure that you're always staying in that +1 to -1 range. Okay, because if it gets louder than that, it's bad news for your ears. Okay. Yeah, and the speakers. Yeah, it's a very unpleasant sound. So, and then now we will do gain slider, set value, and then I'll just put this at 0.5. And then we talked about the text box where it actually shows the number. Right, so we got gain slider, set text box style. Okay, once again, we have to go into gain, into text box entry position, so, or into slider, text box entry position. So slider, text box entry, I always forget. Yeah, text entry box position. And then I'm going to put it below, text box below. Then you have this, what's called a Boolean. So a Boolean could be like something that you want to be true or false. This says is read only. So that means if you've ever seen like plugins where you can like actually like kind of click in there and change the value and then it automatically changes the value of the slider, or if you just want it to be something that they can read but they can't change for that little text box. I'm going to put it to true so you can see it but you can't change it. And then text box entry width. So the size of our window is 400. I'm going to make this 100. Okay, so quarter, and then the height I will make it I don't know, 50. Another cool thing in text box set range is you actually have so we have like the minimum that you want to set it to, which is 0, maximum, which is 1, and then you can actually put a third parameter in here, which is like the granularity, like how much do you want, like when you move it up a little bit, how much do you want it to change. So actually I'll just leave it blank for now. so I can show you what I mean. Okay. Now the last thing that we need to do here in the constructor is we need to actually make it visible on our current what's called a component. Okay, so let me see, how can I describe this? So what you're seeing now on the screen, this is what's called a component. Okay, so it's like, think of a component as a visual element. Okay, now a slider is a component as well, right? So now what I'm going to so now what I'm doing is I'm going to say, oh, that's not what I wanted to do. So now what I want to do is I'm going to say, I want to make the slider visible on my on the component, on my like kind of parent component, right? So I can use this function called add and make visible, and here I just say gain slider. Okay, so that's just saying make my gain slider visible on the parent component, which is just that background color, the background that you saw. Okay, so that's that. Now what we need to do is we actually just need to describe to the editor where on the screen we want to place it. Okay, so I've made this nice. So we have this function called resized. You can do this in Paint as well. I've heard some UI designers actually do all their stuff in Paint, but I guess the kind of correct way to do it is in resized. So in resized, what this does is anytime it, like, you open it up or close it or try to, like, if it's a resizable plugin, if you try to like drag the bottom corner and resize it, then what it'll do is it'll call everything within this code block. Okay, and what we're going to do here is we're actually just going to set the bounds of the slider. So this is how big we're going to make our slider. So we could do gain slider and then set bounds. And so here we have the X position. So X position is going to be, if we picture our slider as like a vertical slider, it's going to be the top left point of the slider, where we want that to start. Okay, so I'm going to say, so the size of our window is 400, 400. So what I'm going to do is I'm going to say, let's put this at 250. Okay, so we're going to the right, 250 pixels. And then we're going to go down. So we're starting at the top left, and now we're going to go down. Let's go down 100 pixels. And then I'm going to set this, the width to 100 pixels and the height to, let's say 350 pixels. And then I'm going to change this to 50. So 250 to the right, 50 down. Then we're going to make, then the 100 is how wide we're making it. We're going to make it 100 pixels wide, and then we're going to make it 350 pixels like in length, or width, in height rather. Okay, so that's how I'm setting the bounds. Okay, so let's just see what we got there. See if we've got a slider. Okay, so I'm just going to compile this and build it. It's going to take a second. So now it's succeeded. Yeah, go ahead.
X and Y, what basically represent?
What do those represent?
Yeah.
Okay, I'll show you once once Ableton successfully quits. So just don't save that. Okay, now we're just going to reopen. Once again, the plugin's been overwritten. Okay. And now we're opening this up again. Okay. And now I'm going to open up the plugin. It's not where I expected it to be, but we see that it is indeed on the screen. And if I change it here, it changes the value. Okay. So just to describe the XY coordinate system for most situations, basically the coordinate system starts at the very top left. Okay, so like if you look at where my mouse is right now, and then you have the X. So X is how many pixels to the right we want to move. Okay, so and then so we're at the top still, and then the height, then the Y is how many down we want to move. Okay, so a lot of people, I know that when I first started coding, I used to have this instinct that I wanted to start down here rather than up here. It actually starts up here in the top left. Okay, and you go to the right, and then you go down. Okay, so if you say x 200, right, which would be, so if you remember, we set the size of this rectangle to be 400 pixels by 400 pixels. So if we said 200, 200, right, that would bring us 200 to the right, which brings us to the middle of the width, right? And then 200 down, which would bring us right smack into the middle of the rectangle. Okay, does that make sense? Okay. Any other questions?
So, like, if you set it to 150, 150, it would be like in the middle. You fade it, seeing as it's 100.
Yeah, so my calculations were a bit off, so I'll have to look back, but yeah, I believe it's 150, 150 is what we're looking for, because we want, yeah, because it's 150, and now we want to go, if the width of the slider is 100, that puts us like, so we got 50, and then we got 50 more, so that should put us right smack in the middle of the, yeah. So the other thing I wanted to point out very quickly is that if you look down here at the text box, you see that we have like this really long decimal number, 0.31777083, right? So going back to what I was saying over here with the set range, right? So we see that the minimum is 0, the maximum is 1, and then what I could do is I actually have a third argument where I could say how much I want the slider to increment by. So this would be like, let's just say 0.01 is a good one. So let's do that. Let's change this to 150. And then I'm going to change this to 300 for the height. And now I'm going to recompile that. I'm going to quit out of this. So let's just reopen, and then reopen like so. Now we can see we're in the middle, right? Like you said, of 150 rather than 250. And we can see that now we have kind of a nicer, cleaner number there in the text box there that is a bit cleaner rather than having a 5-digit.
So how did you do that again? Just to make the number smaller? Was it the third value that you had?
Yep. So there's the third value. Okay. So I put that value to 0.01, which means that when I increment it, it's going to increment at 0.01 at a time. Right? Don't look like you're with me there.
No, I got it. I just why does it then show you less decimals numbers?
Well, that's only because of what I've set that parameter to. So if I wanted to set it, so like let's say I wanted to set it to 3 decimals, then I would just put it to 0.0001 or 0.001, right? So that just controls, truncates how granular I want that to be. Okay. Any other questions? Okay, cool. So, but you'll notice something, right? So when I play this guitar loop, and I have the slider here, you'll notice that when I change it, nothing's happening, right? So does anybody know why nothing is happening?
Because like we haven't linked it to the processor part of it.
Exactly. Yeah. So what we haven't done is we haven't linked it to our processor yet. So we have a slider, it has some sort of value, but we haven't told our processor, hey, processor, we want our gain variable. So if you remember our gain variable, we want this gain variable to equal whatever this number is from our slider, right? So this brings us to a part which is not too complicated. There are more complicated ways of doing this, but this is the easiest way to do this. So what we need to do, like as we said before, is we need to link up the what our slider value is with what our with a number or a variable on our other side that's actually going to control the audio signal itself, the hard math of it. Okay, so the easiest way to do this is what's called with a listener. Okay, so what a listener does is it essentially is it sets up where the processor is going to be listening for changes in where the editor where our editor is going to be listening for changes in our slider. So as we move the slider, the editor is going to be basically looking out and saying, is there a change happening? And when a change actually happens, then what it's going to do is whatever we tell it to do. In this case, it's going to be that we're going to say, okay, we want the value that's in our slider to go over to our processor and actually modify the signal. Okay, is that clear, the way I described that? Okay, so the way I need to do that is I actually need to make my editor, I need to make it a listener. So I basically need to say, hey, I want you to listen for changes in this slider, and when there are changes, when the user makes changes, I want you to relay the value. Okay, so we have this class called slider listener. Okay, once again, it's one of these things like until you start coding and until you've been coding for a little bit, like you just wouldn't know that it existed or that that's what you needed to do, right? It's just one of those things that you just kind of learn over time, or that you get a better instinct for as you get more experience coding. So this is what's called a slider listener. So what I'm going to do is I'm going to use a concept called inheritance to actually add functionality to this editor to make it also listen for any changes. Okay, so the way I could do that is just basically go over here, and then I'm going to add this slider listener class. Okay. And so you may be asking, what is that doing? So essentially what that's doing is so the name of this source file. So to kind of take a little bit lower level for a second, the name of this source file is this right here, Gain Workshop Audio Processor Editor, right? Now, what I'm doing is I'm saying, okay, now this source file, I want it to have, like I said, we're working in a framework. The framework, you're having like some sort of functionality that you want to bring in, like if we were making a video game, I might say, okay, this is the part where I bring in the physics engine, right, for my video game. So in this particular instance, I'm bringing in this slider listener because what I'm saying is, okay, I want this to listen out for any changes that I'm making in the slider. Okay, now there's a function that I need to actually implement here. Okay, so as I said, the slider listener, the whole idea of it is that it's listening for changes that I make in the slider. But in order to do that, then there has to be a function that I actually have to create that actually listens to it, right? So the way that they have this set up is that in order to use this class, I need to actually implement this function, okay? Because like if I try to compile now, right? So if I try to compile, you'll see that it doesn't, that it says build failed, okay? It says, and then here it says unimplemented pure virtual method slider value changed, okay? What that means is that the way that this has been written, it's basically saying, hey, you said that you're implementing this slider listener class, you know, and you want me to listen to changes in the slider, but you've never told me, you haven't implemented any sort of functionality that tells me what I'm supposed to be listening for or anything, right? So that's essentially what that means. Okay, I know it's a little bit kind of complicated to understand just starting off, but that's essentially what that's saying. So what it does is the way that this is written, it makes you bring that functionality in so that everything works correctly. Otherwise you'd be in a situation where you said, I implemented this slider listener class. I don't know why it's not listening to my slider and why it's not relaying the value. Okay. So what I have to do is I have to implement this this function called slider value changed, right? And this essentially tells is where I add the functionality where I'm saying, hey slider, when you change, I want you to relay the value over to the processor side. Okay, so what I'm going to do is I'm going to make this function here. So now I have to tell this my editor what I want to actually happen when the slider value changes, right? So what I'm going to say is if the slider is equal to the gain slider, I'm not going to get you tied down with like pointers and you know, and all that business just yet. Just looking at it from a very high level overview. If the slider is the gain slider, now we're going to relay this value over to the processor. Okay, so now we have just to kind of tell you, this gain workshop audio processor ampersand processor is just a representation of our plug-in processor. Okay, it's what's called a reference to our processor side. Okay, so anything that we need to access from the processor side, we can access it through this what's called a reference. Okay, so there's one problem though, which is that this float gain, I have it in my, so I'm just, if you're following along, I'm in my plugin processor.h. My gain variable is private. Okay, private just means that I can't access it. I can't access that variable from anywhere else other than within plugin processor. Okay, so I can't access it from plugin editor or anything. So what I need to do, you see that there's a section here that's called public, and then what I'm going to do is I'm just going to paste that in the public section there. Okay, so what that means is that I can now access the gain, this gain variable from my editor. Okay, so going back once again, I have this variable that's called processor. This is just referring to my plugin processor. Okay, and I have a a variable in the processor that's called gain. And so what I could do is I could just say processor dot gain. So that's just, all that's doing is that's referring to this variable right here, this gain variable right here. Okay. And then, so it's processor dot gain equals, what do you think it equals here? So I have this processor gain. What do I want that processor, that gain variable to equal? Anybody?
Just one sec. There's 2 equals on the top and then 1 equals on the bottom. Do you want to just explain that on the if statement?
Oh yeah. Let's answer this and then I'll go back and I'll explain the equals and the difference between that and the. So we have this slider value changed, right, which is a function that's going to be called when we're listening out to see when the slider value's changed. Now we have this variable called processor gain, which is just this number here that we have implemented in processor. Now what do we want the gain? What do we want the gain to equal there? Anybody?
The slider value.
Exactly. Yep. So processor.gain is equal to gain slider, and then we just have this function called get value. So we're just getting the value from the gain slider, and we're making that the new value for the gain. Okay. So going back to what Pete was asking about. So this structure here, this what would we call it? It's not a function. It's not a. I'm just going to call it a building block. Okay, so because it's like one of the building blocks of coding, which is called an if statement. So what I'm doing is I'm comparing 2 things. To start this off, like with a very simple example, I'm comparing 2 things, and I'm seeing if they are the same thing. And if they are the same thing, then what I'll do is I'll execute this task. So this double equals, it gets a little bit more technical than what I'd like to maybe get, because I know some of you are just starting off. But this double equals is really just saying, like, look at this, are these 2 things the same thing, right? So the slider value changed is called whenever a user. So if we had 10 sliders, this slider value change would be called whenever a user changed any one of those sliders, right? And all I'm doing is I'm saying, hey, if the slider that's getting changed is the gain value slider, then I want you to set the value of this variable called gain to whatever the value is that I have in the slider. Okay. Anybody have any questions about that? Anybody? Okay, so I'm just going to compile that. And then we will open this up. And then just open up our project. Okay. Ooh, so it didn't work. Interesting. Right? So it hasn't worked. I know why it hasn't worked. I forgot to do something. So the only other thing, and I forget this all the time, is I need to add the gain slider as a listener to this component. So we have gain slider dot add listener, and then in here there's this keyword called this. This just refers to like the actual. So like I was saying before, this editor is referring to like the background component, right? So what it's saying is, I want this component that I'm in right now, the background, the actual kind of rectangle that I'm in right now, to listen for whenever changes are happening in the gain slider. Okay, a little bit tricksy to kind of get your head around, but that's essentially what it is. Okay. Anybody got any questions about that? Did I explain that properly?
So,
Yeah.
so this, it's like you're in the this currently, and you're referring to the gain slider, and you're like, gain slider, add listen to me this.
Yeah.
Right.
Yeah. Essentially, yeah. So I've just compiled it again, right? I'll explain it to you when I reopen Ableton. So this actually, so you remember, like, I took the editor, the editor, and I changed the background to black, right? So we know that this right here is referring to the editor, essentially, like what we're seeing. Okay, so when I say gain slider, add listener, this, I'm saying I want this component, which is the parent component, to listen for changes in this slider. Okay. Yeah, does that make sense? Okay, so now it should work. So now we see that it's working, right? So we've just made our first plugin. There it is. All right. So now we'll do one more little small thing. It's just a little small thing, which is that if we take a look just down here at Ableton itself, we see, like, okay, well, this is not going from 0 to 1, isn't it? It's going from like -60 to 0. So like if you've ever worked in a DAW, you know that 0 is kind of the max value. 0 dB is the max value that you can have without distorting. Now, Pete probably, I'm sure Pete knows more about this than I do. So basically what we're going to do is we're just going to change this value of 0 to 1 to the decibel scale. Okay. And there's a simple way that we could do this actually in Juice. And so what I'm going to do is I'm just going to change, go back here to the editor. I'm just going to change these values here. And I'm going to do gain slider set range. I'm going to change this to -40. Change the max to 0. I'm going to leave that value. Now I'm going to change my set value, my default value, to like maybe -35. And then I'm going to go to my processor. Now I'm just going to change the default value of that, right? Because I don't want it blowing my ears out. Because 0.5, when I was going from 0 to 1, was half volume. But 0.5, if I'm talking about decibel scale, means above 0, okay, which means like distorting and would not sound very nice, okay? So I'm just going to put the default at -35. So these are the types of things that like if you're not careful can really kind of trip you up and be painful. So be careful whenever you're trying something new like this. Like listen at a very low volume, just to test it out. I say this from experience. Okay, so Juice has a class called decibels. So let's see here. So there are so many different little things that it has that you just don't know until you've seen it in another person's code, or until you've had the sense to kind of look it up and say, oh, maybe Juice already has something like this, and I didn't have to, because otherwise there's a formula that you can use to actually change the gain, which is going from 0 to 1 to decibel scale. But luckily there's something that automatically does it for us. So we got this decibels to gain. Okay, so what I could do is I could do, in here I could do decibels to gain. Is that what I want? Yeah, type decibels. Yeah, once again, make sure you get this right, because if not, it could be a painful experience. Okay, so so that's the function that'll actually change the decibels to that raw gain value. Okay, and if you're curious, you could say, okay, well, what actually happens there? I've never actually tried this, but you could actually go in here, and this will actually show you the formula that they used. Okay, so that's it. Okay, any questions about that? Anyone?
Is there any difference apart from just the workflow of writing in the formula as opposed to having the juice do it for you?
No difference really, but I would say, like, if there's a juice implementation, just because as a framework and as developers of the framework, they're so focused on optimization, on making it like the absolute, like, most efficient that it can be.
Yeah.
So I would just go with whatever juice implemented, if
Sure.
but there wouldn't, theoretically there wouldn't be any difference.
Yeah.
It's really easy to implement it wrong as well.
Yeah.
Or do it the wrong way around, and then you're in a mess. But
Yeah.
it's good practice to kind of do it at some point to just get used to doing it. But
Yeah. See how I just like turned that down just to make sure. I just speak from way too many experiences. And see, now we see that we're in decibel scale now. Yeah. So that's it. Yeah, that's basically it. That's basically your first plugin right there. Yeah. So any questions? Anybody have any questions? Anybody? I'm gonna check on the chat here as well and see.
did you want to mention about automation as well?
Yeah. So
just a quick one.
yeah. Yeah. Go ahead.
So you set the default level to -35.
Mm-hmm.
So when you play it back, there wouldn't be any modification on the original signal at -35 on the fader.
So zero. So if I had it at 0, there wouldn't be any. So if I have it at -30.
If you wanna add some gain,
Yeah.
you can't do it with this. All right.
Yeah. Well, not the way it's existing now. Yeah, you could change it. Where if you wanted to add gain, you could go up to, like, I think most add up to like 40 dB or something like that of gain. Yeah. Another thing that I should do here. So as I was saying, there's a great, like, kind of safe stop to keep from blowing out your ears, which is to add a hard clipper at the end. So big shout out to Ivan Cohen if he's watching this, because this is something that he taught me. So what we'll do here is we got channel data and then sample. And then there's this, once again, you wouldn't know it unless you've worked in Juice. There's this function called JLimit, which actually constrains values to whatever you want to constrain them to. So if you say, I only want this to be 0, between 0 and 10, then you can put 0 for the first parameter, 10 for the second parameter, and it would actually it would actually constrain it between those values. So, so let's see here. So let's see, because decibels the gain now. So, oh yeah, so we got the channel data. So once again, the channel data is the audio stream, right? So now what we've done is in this line above, in line 147, we've actually changed that, right? So that's going to be multiplying. That's going to be multiplied by whatever our decibel to gain ratio is. Okay. So what's going to happen is that our result is going to be channel data. The channel data at each sample is going to be raised or lowered based on whatever we've done here, right? So now what I'm going to do is I'm going to say, okay, I want the because I don't want the audio signal to be distorted. What I'm going to do is I'm going to keep this in between -1 and 1. So these values, no matter what I'm doing in line 147, I'm going to make sure that the audio signal always stays between -1 and 1. Okay. And then my final parameter is actually just this channel data sample. Okay. One thing that you got to do with this function JLimit, kind of a thing that's probably beyond the scope of this class, is you've actually got to specify what type of what's the word? I'm losing my words here. What type of, what's that? Yeah, I didn't want to say variable. Granularity, so whether you want this to be a float, a double, or an integer, basically you got to specify that there. But don't worry about that. That's beyond the scope of the class.
Do you reckon there's any use of doubles, or like is that going to be like what every door and every plugin's going to be these days, or do you reckon floats are going to be?
So it depends. So like for people that don't know, double. So double is like a float. So like I said, a float is a decimal value, but a double has more. I want to say it has twice as much granularity as a float, but I don't know if that's right or wrong. But it has more. I can't remember how much more. I think a float is like 4 bytes and it doubles like 8 bytes, something like that. So it enables you to get much more granular in terms of like how small you could get with your decimals. So there are certain times. So most times you use a float. So like you see here, like if we look at our actual audio buffer, it's in float. It's not double. But there are certain cases, I think, where people use double. I think, like, so I think, like, when you're creating a wavetable, do you know what a wavetable is? So, like when you're creating, like, a wave, so, like, one cycle of a wave for a synthesizer, I think that some people, some developers actually use that with using a double rather than a float, I think, just because it gives them more granularity and it's a little bit more kind of, you give it a little bit more specificity. Is that the word? Is that the right word? But yeah, there are certain times where you want it to be a double, but a lot of times a float is okay. I say this cautiously, but I'm just afraid of the C++ gods cursing me.
So that's like on the level of amplitude, right? So how related is the being a float or a double to bit depth?
So it wouldn't. So bit depth is referring more to the number. so you wouldn't, so you don't have like double precision in the bit depth determines the precision
Yeah.
of what you're looking at in terms of bit depth. So
The
bit
current
depth,
available values there are.
yeah.
Yeah.
So I think for 16-bit, I think it's like 35,000 or 65,000. I think 65,000 values. So that gets a little bit more kind of into DSP theory, but so it's the bit depth that determines like what that is, rather than the whether it's a double or a float. Yeah.
Double or a float is the number of mini steps between -1 and 1, right?
Yeah, that's the bit depth. Yeah. So, yeah. So the bit depth. So the bit depth is what? The bit depth would refer to the 65,500 or whatever steps that you have between -1 and 1. Has to fit in one of those. Double or float. In terms of precision, what would that do for a wave? Yeah, it doesn't sound like it would do. It doesn't sound like it would do anything because it would still need to fit into that 65,000 values. Is it 65? I'm like really curious now. To the 16th. Yeah, 65,536 values. So double or float in terms of a wave. Yeah, I'm gonna cautiously say that I don't know why you would do that. Yeah. Yeah, it
Calculation rounding error, maybe.
I'm trying to think of where I've actually used double a double like in over a float where I've wanted that level of granularity. And I can't really think of a situation at the moment. Yeah. Great question. Something to actually look into. Okay, I'm going to, let's see. Are there people still watching, or did we disconnect? Let's see here. Oh no, I don't know if I've actually been broadcasting this whole time. Oh, where are we? Oh no, we're still live. Are we live? I think we're live. So yeah, 18 people still watching. Wow, how cool is that? Wow, so cool.
Someone's answered as well.
I'm here. Oh yeah, here we go. So somebody named Chris says you don't need to specify the type if all the arguments are explicitly the same type. Oh really? Okay. But it didn't work though, Chris. When I tried the J limit without specifying the type, it didn't work. Float and doubles have an order of magnitude and amplitude values. Maybe I'd use double for something very fine like the phase of an oscillator. And Matthew Fetcher, big shout out to Matthew Fetcher from AudioKit. Anybody use AudioKit? No. AudioKit is the bomb. We always choose doubles over floats over here at AudioKit. Oh man, Matthew, man, we're in the presence of a celebrity right now. Big shout out to Matthew. Cool. Yeah, that's the argument of floats and doubles. I know that there have been other arguments about this before, so yeah, something I definitely want to look into. But in terms of more granularity in terms of bit depth on the y axis, that would refer the bit depth would determine that how many values you have there. So having a double wouldn't give you any sort of, as far as I can tell, wouldn't give you any sort of like extended granularity on the Y scale. So, okay. So, other questions?
Would you always use that J limit on the finished version, or is it just for debugging?
I would use the J limit on the finished version. Absolutely. Yeah, because even, no matter what your signal chain is, you want to make sure that the signal that's coming out is staying within the limits. So I would. I mean, I know a lot of plugins don't, but I personally would. Okay. Yes.
Can you go back to code?
Yeah.
There was a G limit of -1 and 1. Is it the gain like level or is it decibels? Maybe if we change chain and sample to
Yeah.
decibels.
So a little bit. So I understand what you're saying there. A little bit confusing. So if you look at line 147, we have channel data at. So this is saying each sample within that buffer, right? What we're doing is we're changing it. We're multiplying it times whatever our gain ratio is, right? So are you with me so far?
Yeah.
So whatever the answer to that is still going to theoretically be a value of between -1 and 1, right? Because once again we're talking about this audio wave that's going between -1 and 1. Okay, so you have two separate things, or you have the gain, whatever the gain value is, and then you have the wave itself that's going between -1 and 1. Okay. Yeah. Other questions? Yeah.
Just on the top of your limiters, it's kind of off topic of what we're talking about now.
Sure.
You talk about like a limiter kind of comes down and it won't allow any values above the threshold. I'm kind of like thinking about like upwards compression. Like, could you have like an upwards limiter where it doesn't allow any samples to go below the threshold, and like how would that sound? Does that exist? And I haven't found it.
I don't know. To be honest, that's outside of my dimension.
Okay, cool.
So you're saying like a minimum value?
Yeah. So like if below this minimum value, pin at the threshold.
Okay.
Yeah, but like instead of having it go to 0, have it stick at the threshold.
So then it would just like be just down at whatever lowest.
I think the problem that you've got is that when you're on the J limit, it's -1 to 1, but when you're dealing with audio processing, generally you're not thinking about the negative numbers.
Yeah.
Or you're only thinking about it as like an absolute value.
Yeah, that's true.
Not
Yeah.
positive or negative, just as
That's
one
true.
thing.
Yeah.
So it doesn't really matter. So the J limit is just something that you wouldn't see in a door.
Yeah,
to
yeah.
hide that from the user.
Yeah, with you, yeah.
Yeah. Whereas you obviously get upwards and downwards compressors that are working below whatever your threshold point, and that's fairly simple to
Yeah.
to do.
Yeah.
Really. Yeah.
Yeah, I mean, yeah.
Cool.
So there's one person in here that says, I wouldn't use a hard clip limiter in a plugin that isn't supposed to be a limiter, only for testing, because if your plugin is in the middle of a signal chain, someone might send it out at +12 dB, then scale it down at -12 dB in the next plugin. Yeah, I guess my argument would be that if you're at +12 dB, theoretically you'd be digitally distorting, correct?
No, because the internal engine of Pro Tools is 64-bit, which has a floating point,
Okay.
where it can't possibly clip until it goes out of the computer through the interface.
I see.
So internally, most modern DAWs will allow you to clip as long as you bring it down before it comes out, and that's what that guy's saying.
Okay.
So yeah, it means that if your plugin was there for people that were really inexperienced and not used to music production or general consumers, you might do that to protect them and their speakers. But for an audio professional, you've got to think, well, maybe they know that and they'll allow it to clip.
Yeah.
Because they're just going to bring it down in the next plugin or somewhere else way down the line in the chain.
Yeah, very interesting. Great stuff. Okay, other questions, coding questions, audio questions. Anybody?
Like through APA called it, like choose
API?
counter?
Um,
Yeah. Basically, can you go like on Wikipedia page where you can go just kind of connecting points? You basically go to a slider, from slider go somewhere else, and have not finding one by one on Wikipedia going back always, but actually it doesn't have any helpers to go forward and forward and forward. I don't know if I explained correctly. Basically, like if you go to a slider, it will get you, because when you use slider, you probably will need something like the position of slider.
Yeah.
Does it send it to the code?
So like if you wanted to get the actual XY position of the slider, is that what you mean?
Basically, using juice that form, not form, like AP. Maybe I'm getting lost in information. But,
Yeah.
it just, I'll check it myself.
Okay. Yeah.
Someone on there asking how we can achieve unity gain.
I don't know. I forgot what unity gain even
It's
is.
0, so it's just how it came in. So it's actually
Oh.
nothing. So
Oh yeah. So yeah. So it's just multiplying it by either if you're working with raw gain, then it would be multiplying it by 1 or multiplying it by 0 if you're
yeah.
if you're working in decibel scale.
Yeah. So unity gain 0 dB. Yeah, that's dBFS. Yeah.
Yeah. Okay. So, yeah, DAWs don't clip internally. Even floats, I believe, have a dynamic range of like 1500 dB. Okay. Can I come to a university in Germany? Sure, I'd love to. Cool. Wow, interesting. Any other questions? Anybody? No? Cool.
What's the most complex plugin you've worked on, or audio project you've worked on?
So the most complex thing that I've worked on has actually been an app, a DJing app that I'm working on, which is it's almost like DJ Hero, but using actual DJ equipment.
Mm-hmm.
So where you have to, so like Serato or Tractor, right? So where there's an example that's played of like a scratch that you're supposed to do, and then you have to imitate the scratch, and then it scores you on how accurate you are. And that has been pretty complex in the way that there are a lot of different things that need to, so you have to have like file loading, so you have there are loads of different things that it has to do. So you have like file loading, so it has to be able to play a file, it has to be able to you have like a metronome in there, you have points where it's listening to what the user is inputting, and then there's points where it needs to score between like what the user's inputting and what they're supposed to be doing. You got drawing, you got like graphics drawing in there. You've got, and then you have recording, so you have to have a place where like people can record new examples. So yeah, that's been the most complex one. You have different settings. You have where it has to, you have like MIDI, so you have to be reading from a MIDI controller in real time. Yeah, there's quite a bit. I don't know, like if in the eyes of other people, like in the eyes of like people that do this as like a full-time developer, I don't know if it would be considered complex. I think it's pretty complex.
Yeah, sure.
But yeah, so that's about the most complex thing that I've ever worked on. Yeah. Yeah, but
It feels like you have to kind of have a separate I'm gonna say, dedicate separate time and effort to learn Juice as
Uh-huh.
well, because otherwise, like, well, I know C++ is like the core of everything you do in Juice, and
Uh-huh.
Xcode and everything, but it's quite a lot of stuff within Juice, isn't it?
Yeah, Juice itself is a lot to learn. Especially, I think, and maybe somebody might tell me if I'm wrong, but I think that a lot of these type of frameworks, and I say this from like just speaking blindly, just from like kind of hearsay, they operate kind of on the same sort of paradigms, in terms of like we were saying with the processor and the editor, that there's something kind of happening on the front end, and then you have to have like something that's listening for it, and it's relaying that value over to the back end. And so I think those sort of design paradigms are quite similar between a lot of the frameworks. This is from what I've heard. I'd say this from like no or very little experience, but that yeah. So I would say that once you have those kind of design patterns and you have an understanding of how those design patterns work, you could probably flip between frameworks relatively easy. But I think just getting set up the first time and really just understanding the thought process of, especially that thought process between what you're seeing on the screen, like in terms of like what's happening in audio, and like when the plugin or when the audio app is actually requesting to like repaint the screen, so like to update the graphics, when that actually happens, as opposed to how often the audio actually updates, and things like that, is really like, once you have that under control, I think it becomes a lot easier. But there's a lot to understand for sure. There's a lot to understand, and even from a C++ perspective, C++ is such a big language. I mean, I really try to think of C++ almost like there's like this rule that's called I think it's called the 2080 rule, which is that 20% of, like, so if you look at like C++ as like a complete language, that or if you look like at a spoken language like English, let's just say English, there's actually like 20% of the actual English language makes up 80% of our actual like communication. So like if you learn 20%, so the theory is that if you learn 20% of it and you know that 20% really well, that's going to get you through 80% of the situations where you're speaking English. And that would, yeah, I was going to say that I think that applies well to C++ as well. So like a lot of people get very intimidated by it, but I would say, like, okay, once you have the basic fundamental concepts of it, you can move your way around it. I think it's really those like kind of edge cases and like little syntactic kind of things that kind of throw people or like, really kind of push people away from C++ sometimes. But I think once you have like the fundamentals, then you can work your way around, and then the rest of it you just kind of figure out as you go.
Like from my perspective, it feels like the three main things that you really need to know to do this kind of stuff is like know this basic C++, or well, to start with. Then
I would say if you learn C++ really well, like if you had to pick between like anything to learn well, if you learn C++ really well, like you'll be fine.
That was going to be my question.
Yeah.
What do you think is like the least? Well, everything is necessary, but what do you think is the least necessary? Assuming that when you do stuff like that, you use a lot of like build blocks already, just ready to go, and just need to make it work for your purpose.
Yeah.
So what knowledge do you think is like the least like necessary?
The least necessary.
Or the one that you should put more effort than in terms of. Do you get what I'm saying?
Yeah.
Like, I assume that if you know how to work around C++ and you have access to the blocks, of code,
Yeah.
you might be able to piece them together. So,
Yeah.
So then, the challenge will be the maths.
Yeah.
Yeah.
Well, I would say that for a lot of situations, like a lot of people, they want to go math and they want to go DSP, but a lot of situations you don't really need to go that deep. It's more about the implementation of the math than it is about the math itself. You know, like if you want to make your own crazy, delay that sounds completely different from what other people are doing, then you have to know the DSP for sure. But a lot of tech offices that I've like a lot of companies that I've been around, I would say that many of them have one to three. When I say three, I'm talking about like larger places, like some place like Ableton. But a lot of places only have like really one person that is like their DSP guy. He comes up with the algorithms, and then the other people are like more kind of generalist or like specialize in certain areas. But a lot of times, in many companies, you'll have one or two people that are like, these are the DSP people, these are the DSP algorithms people. So the fundamentals of audio are really important. Like stuff, like there are certain kind of rules in terms of like stuff that you should do in that process block, the audio callback, where all that audio action is happening. There are certain kind of do's and do not do's there. Understanding like buffers, sample rates, bit depth. DSP basics is really good. It's so hard to say like focus on this. Focus
I'm
on.
just asking because like remember my first classes were
Yeah.
C++, and it's still like doing another online course aside.
Yeah.
And in certain times they always say like, oh, don't worry about this bit now, you're gonna get it.
Yeah.
So
Yeah.
so and I ended up getting after when I understood the whole thing. I was like, oh, so this means this.
Yeah.
So I'm thinking here we have like more than C++. In C++,
Yeah.
you see stuff and like, oh, right, don't worry about it, you're gonna get it later, and you actually get it. But here you have the language, you have the framework, and you
Yeah.
have the maths.
Yeah.
And when you're going through everything, I was like, right, I understand this, but I don't understand that. And I don't know if it's the kind of stuff that's like, right, you start doing it and then you're gonna get it, or if I just saying it like try to get a bit more background, a bit more of like solid
Yeah.
C++ to then do it. Do you get what I'm saying?
Yeah. My advice on that is build real stuff that works. And what you'll find inevitably is that as you build, you're going to run into these things, these issues, and that you'll naturally just kind of, you'll struggle with them and you'll overcome them, and then that struggle of being a developer is like a normal struggle, but so some people favor this approach of let me learn like the C++ language really well before I jump into Juice. I don't really subscribe to that. I really feel like get in there, get your hands dirty, build stuff, make mistakes, run into the wall, ask questions, but build things. The bottom line is build things that work. They can be simple things. They can be super simple. Like they don't have to be like the most complex things, but they just have to be things that work. Because the most important thing is whenever you're applying to any job, the first question somebody's going to ask you is, show me something you've built, show me something you've coded. And they're going to be able to look at that code and they're going to be able to tell right away like what level you're at, pretty much. But build stuff that works. Don't, people say like, there's a lot of, I would say that there's a lot of fear that is quite natural for developers to have, like, I don't want to mess up, I don't want to do it the quote unquote wrong way. Yeah. Like one person that I know that never really stuck their head in the textbook, and this person's like an anomaly. Is this guy named Steve Duda, who's the guy that created Serum. We've had conversations, and he said, like if you saw the way that my code was written, you would just cry, because it's just all over the place. It's all like, it's not like in classes properly. It's just like this big long thing of code, and it's probably all spaghetti, and and it's crazy. But he has the best selling synthesizer plugin on the market. I mean, and that's where I look and I say, you know what, as a person that's been around like a primarily a C++ community, I think that sometimes we get a little bit too focused on the optimization, doing it the right way, rather than just do it, create something. And when things go wrong, naturally you just get by and you say, okay, well, what do I need to do? What do I need to do to fix this? And you naturally fix it. So, oh yeah. So let's read the comments here. Matthew Fletcher dropping knowledge here. Try building something simple and learn as you need them. Yeah, exactly. Like Matthew Fletcher, who from AudioKit, he's had two number one apps audio apps on the App Store, and he says try building something simple. I mean, I think that like I said, I think that's so important. Some people try to build this big complicated thing that just never ends up working, and then you don't have anything to show anybody.
That's because it's hard to find, like, if you search on the internet or YouTube or anything, like tutorials of how to do like a specific task on juice or anything.
Well, that's Joss's channel right there.
Yeah.
So I'm gonna have a look actually, because like I find hard, because there's a lot of like, things that you have to know to be able to do it. So the maths knowledge, the juice, the simple skills.
Yeah.
It feels like you're never gonna get all the information in one tutorial. Do you know what I'm saying? Like, so if you wanna know how a compressor would work behind the scenes, you might have like some mathematician or someone explain the maths. Someone explain how to do the code and everything, but you're never gonna get one person explaining you the whole thing. Do you get what I'm saying? It's kind of like tricky, because if you don't have a really good C++ like knowledge, sometimes you just end up like, right, I get it, but at the same time I can't do it because the math's missing or something. Do you know what I'm saying? It's kind of like, it's weird to find out.
Yeah. Well, there are people out there that know how to do it. And actually, on the subject of like compressors, DSP stuff, we're working on a solution for that. Something that'll give you the theoretical and the code. There's actually a really good book called Building Audio Effects in C++. There are actually two great books. Like if you're looking for a book that has the math and the coding, there's one called Building Audio Effects in C++, and there's a recent edition of that's come out earlier this year. That's by an artist. That's by a professor called Will Perkle. He teaches at University of Miami. What's that?
Ron Perkle, did you say?
Will Perkle.
Will
Perkle. And then there's another book that's great. Only thing is that it's written in MATLAB, but easily transferable to C++. It's called Hack Audio by another professor at Belmont University named Eric Tarr. And both of those books are like fantastic. They teach you from So they teach you from a coding standpoint, from a mathematical standpoint, and they're really good. But yeah, it is a struggle, and it's been something that as a person or as somebody that's part of a movement within audio education, we've been thinking a lot about in terms of like, even for audio developers, the array of things that you could be working on could be a wide array of things. Like if you're working on a DAW, you're going to have different considerations than if you're working on a compressor, like a VST compressor, because there are just different considerations, different things that you need to know about. And as a learning lesson for everybody, even people that've been doing it for.
Do you have any good website with like open source so we can have a go with a few things? Because like if of course I'm just starting,
Yeah.
don't want to jump the gun.
Yeah, so I mean, there's a lot of stuff like through the YouTube channel. You can get there's a lot of code that shows you a lot of the basic fundamentals, and then also there's if you just go on GitHub and you search Juice, you just search for Juice. Like there's some fantastic stuff out there. There's a great
Your channel again?
the audio programmer. Yeah.
Eric Tarl's channel is already good as well. But that's
Yeah.
that app, but really good as well.
Yeah. So, great. I'm just going to reply to.
Cool. I'm just going to kill the HDMI so I can get that.
You need help?
No, I'm good. This is the last of it. Just they're really picky next door at the Media Resource Centre.
Are they?
Getting stuff back on time.
Yeah. They charge you £6, innit?
Do they?
What?
Yeah. Like this last year, yeah.